Hi, my name is Ian Searle. I'm presenting my lab two for embedded systems at Purdue University. In this lab, we use basic and fundamental principles of embedded systems, such as PWM, real-time clocks, timers, ADCs, to control the value of a LED's brightness, the values of an LED's brightness, and its frequency. We'll walk through the code once we've gotten it started and running. So we're just going to go ahead and run it from up here. We're going to go ahead and put in the current time. And you can see that we put in a number for the day, and that is 0 being Monday. I'm going to say we're about 30 seconds into the minute. So, well, I don't have a reference for the minute, but I do have the reference for the time at the bottom. So right now we can see that the board has engaged and started to do its thing. We can see it blinking here with the joystick doing nothing. We'll take a deeper look at the code at the end of the video. We'll take a deeper look at the circuit at the end of the video. Right now, we're going to be looking at the code. So we'll walk through the code and I'll explain everything that I am doing. So the very first thing we have to do is import. And there you can see just really quickly, right there, right there. We just got the most recent time. That is showing us that every 30 seconds that everything is running correctly and that we have the correct date and time and we're moving things correctly. So the first thing that stands out is this weekday decode. This converts the number that we put in into an actual day. We also have some start mode, pot frequency, and pot duty. These are our control states. These are just kind of placeholder variables or flags that we can say that allow us to use written language instead of numbers to define our control state. We also have our debug flag. Our debug flag is something I included where this microcontroller does not have a built-in debugger. This allows me to activate print statements with a single line of code, and as well as some other debugging functions if I want to put those in. Here we have our setup. We start off in our start mode state, and then we have the initial pot use frequency and the pot use duty cycle. These variables will be updated later. We also have our global PWM, ADC, setup, our RTC and watchdog timer with a 30-second timeout, as well as we set up our button pin, our potentiometer value to a default of 0, where we're going to be calling this multiple times, as well as a debounce timer. I include this map value function. I really like mapping values. You give it the current value that you want to map, the input and output mins and maxes of that, and then it will just automatically find where that is. Instead of having to rewrite this line of code every single time, I find it works really well, and I can just copy and paste it into different things. So this is where we change mode. So this gets called by an interrupt handler. We'll look at that right now. So we have our button debounce. So once a button is pressed once it detects a falling edge, it will just say, hey, make sure it's not a multi-button press and it's only 50 milliseconds, in which it will go into the control state. And the control state, if it's in the start mode, we immediately will jump over into pot frequency. Otherwise, we'll just start toggling between those two states. I could do this with bit banging, but I felt like in Python, I didn't need to focus so much on the optimization. I'm not really constrained with my resources at the moment. I do just want to acknowledge I could make this code a little more optimized if I wanted to. So here we have our setup for getting the input from the user. I just have all that. You can see I make sure all of them are ints, otherwise the program crashes. We also have our print. This will see at a later time return and be called in as a timer every 30 seconds. And you can just see this is where we get our weekday. We throw in the weekday, which is the third thing into the date time, which we can see, sorry, the fourth item in the list, which we can see in our RC datetime setup function. We then just print all of that out as displayed down in the terminal output. And then our most complicated and I would say central function to this is the read potentiometer or read pot function. We take in those global potentiometer values and we just read the potentiometer. And then we see if our control state is in pot frequency or in pot duty cycle, we'll actually go in and edit those values. So in start mode, it just jumps over those. In the case that it is one or the other, we'll look at pot frequency. It will take the current value, we would say, or the prior value from the last time the function was called, stored as the old value. It will then take that, map it out to whatever range I've set. I've set 25 at this moment. So for the frequency, so we'll only see it between 1 and 25 hertz. It will map that, and then if the values are not equal, it will change that. I just found that that was a little smoother for me, uh, and so that's why I did it as that. It doesn't need to happen. I just find it works nice. And then just the exact same thing for the duty cycle, just a different values into the map function. We will also have to feed the watchdog timer every time. We want to make sure we feed it. And then we can see some of those debug print statements. And then we will go through the setup phase. We can see we get everything set up. And then here we have our timer. So we set up our timer 0 to have a 30-second callback, and it will just print the date. We will also call the read pot every 100 milliseconds. And other than that, once we get the board set up, we go into the idle state, at which point the board runs. And now let's take a little closer look at what's going on the board level. So here we have our circuit. We have our LED connected to GPIO 15. Our potentiometer is followed by this blue wire down to GPIO 30 board button. We're using this potentiometer as this is just one I had on hand. It's actually two potentiometers, but we are currently connected to the Y X direction. When we start our program, we can see that the LED begins to do its thing and just blink at the preset frequencies. We can see that the joystick has absolutely no control over the frequency or the brightness. Upon pressing it, we will see that the brightness increases and the frequency increases, sorry. We can see that here. We're decreasing and increasing that frequency. We're going to go to a higher frequency. And now we can see that we are really only changing the brightness of that LED. Pressing it again allows us to change that frequency. Thank you for following along and standing through my videos. Thank you.